Hi guys. Oh, this is the second video today, man. We're going to start on ion equilibrium, the last part of your physical chemistry. Okay, after that, we do your inorganic chemistry. Now, I'm going to just do the two parts here, the first two parts here. Okay, I've got a different PDF here, which I just cut and paste to make it easier for everybody. Okay, I'm just going to go on the main key points of this part here. All right, we are going to talk about, now you look at the main structure. Okay, same. Okay, explain the terms of pH, right? What is pH? Of course, you should know pH is equals to minus log base 10 concentration H plus within lower 6, where this one, the concentration is equals to, I don't know why this is blocking it, doesn't matter. The concentration of H plus is equals to, of course, moles per dm cube. Okay, moles per dm cube. Otherwise, this moles per dm cube. Important, okay, right? Ka, of course, Ka is come from Kc. You know that for acid, now this, they ask you, no, okay, Ka, here, okay, put Ka, yeah, Ka, essentially same as Kc. Why? Kc, of course, you learn, when you use Kc, you learn in your lower 6 for equilibrium system. Now for acid, that is Ha, this is the general equation, okay? It gives you, H is the proton, A is an ion, HCl minus HCl, okay? H plus, and of course your A minus. So your Kc is equals to H, this one here, concentration in moles per dm cube over your concentration of Ha. Now this is frequently asked. Of course, Kc here, because it's acid, equal Ka, right? If it's base here, of course, if it's base here, it's Kb lah. Okay, right? You can see after Kb is for base. This is the equilibrium constant. All right. So they ask you on this pKa. pKa is of course P, like say pH. pH is equal to P is a function, that's all. P is equals to minus log base 10. That's all. Whatever that's here. So pH is equals to, sorry about this, pH is equals to, okay, minus log base 10 H plus. Must put the base 10, you know. So if I talk about here, so pKa is equals to minus log base 10 Ka. Okay, remember for pH, the smaller the value, they ask you also, smaller the value, more acidic. Okay, acidic. Here also pKa, the smaller the value, also more acidic. Okay, they ask you. We did this before in your organic chemistry, if you remember lah. Of course, you don't remember lah. Okay, Kw, of course, you see after is for water. Kw is very simply, maybe here, expression for Kw now, okay? Kw is basically, like, for example, for water also is reversible, H2O, right, reversible, go to H plus OH minus. So you can put Kc is equals to H plus and OH minus. A question hopefully came on this, okay? Of course, over water, it's such a large amount of H2O here that is a constant already. So you bring it up here, if you bring it up there, it will become what? It will become equals to, I put down here, H2O and Kc equals to H plus and OH minus. In fact, this is at 25 degrees centigrade. Remember, temperature is so important. It's 1 to the power of minus 14. Okay, and that's why you see this the concentration of H plus is equals to OH minus of X equal to X. So you know that X squared is equals to 1 to the power of minus 14. So X or H plus is equals to 1 to the power of minus 7. That's why pH of water is equals to 7, right? Because pH is equals to what? minus log base 10 to the power of minus 7, isn't it? 7 here. So it's 7. Okay, so that's the reason why. Okay, so using calculations, the whole thing is today is all in calculations. So you use a log, things like that. Okay, I don't know why this thing is not playing up with me. Okay, remember this is the keyword. So your maths is lousy, then you forget it. Don't do it. Okay, calculate H plus concentration and then pH values for strong acid and weak acid. Okay, now we're going to consider weak acid today. Strong acid is very simple. They ask you also on define what is strong acid, what is weak acid. Okay, let me just give you a question on this, page 28 here. Okay, 28. They ask you about that. Okay, we go back to form 4, form 5. Okay, explain the difference between strong acid and weak acid. 1 mark. Okay, now the answer of course is completely weak acid is partially ionized and no mark. Strong acid is completely ionized. You consider completely, it means 100%. You don't say 90%, even though it's always never complete one in reality, but complete. Okay, here is partially, maybe 3%, 4%, 3%, 4%, whatever. I don't care. Right? So they ask you on this kind of thing here. Okay. Now they ask you of course on definitions of acids. Okay. Just give you the question first. Okay. Page 11. I don't know why the things are coming out. Never mind, here easier for me. Okay. I'll give the okay. Just let you see. I want to go faster so I can finish on time. See, what is meant by Lowry and Brownstedt theory of acid and bases? 2 marks, no, 1 for acid, 1 for base. Why not? Remember, you did this where? You did this in your lower 16. Remember, Lowry and Brownstedt, okay? Right? So acid and base. Remember, Lowry and Brownstedt is a proton acceptor, proton donor, right? Because I give you here, if you remember lah, but never mind, I put down here anyway. Okay, here. Oh no, I see. Okay, so I didn't put it down here. These are all questions. Okay, of course, in your unequilibrium, your main notes, there is that here. All right, see. Okay, this is your main notes. At Brownstedt Lowry, acid is what? Proton donor. That's all you need to know. See. Okay, proton donor. Okay. I don't know why it's not. Okay, must press the button. Okay, proton donor and base are proton acceptor. Now, this is the idea of conjugate pairs. Let me just explain. Okay, now HCl equals, is it acid now? No, because this equation gives you H plus, Cl minus. So now H plus, right? This fellow here is an acid. Why? Donate proton one. Why? There's the formation here. Okay. Now Cl minus, is it a base not? They say it's a base. Why? A base is a proton acceptor. How do you know it's a proton acceptor? How do you know? Well, there's the arrow going backwards now. Yeah, that means it can. See now, it's a proton acceptor. Cl minus is the base. Now these two, they come from each other. This is the acid, this is the base. This is called a conjugate pair. That means they came from the same source. Okay, conjugate pair. Now let's say I put H2. I put HNO3. Okay. Also, we'll go to H plus. And of course, the NO3 minus. Okay, so this is an acid. Why? Proton donor. Proton donor. Okay, that's right equation. This is a what? A base. Why is it base? Because the proton acceptor. How do you know? Proton acceptor. How do you know? Because there's a sign going back. Okay, going backwards here. That means it can accept proton to go back here. Now these two pairs are called what? These two pairs are called conjugate pairs. This is a conjugate base of this conjugate acid. But this, even though it's a conjugate base, and this one here, they are not conjugate pairs. No. Remember, they must come from the same soil, the parent and the child must be same. Okay? So now here's a couple of things you can read over yourself. Okay, now this is an acid, this is a base, conjugate acid. Now this one can go two parts, this one came up before. Okay, so here go to H plus. This one go here to give you plus H plus. So this one can act as a base as well as an acid. Okay, so you can see because it can have like 2 Kas, this is Ka1, this is Ka2. Okay, now water can act as water can act as an acid because plus H plus, okay, right? Now water also can act as a base because the H plus, this one here, plus H plus, remember not, can go to what? Can go to this one, isn't it? Right, the hydrogen ion, right, can act as a base because the proton accepted, see now, okay? So water can act as a base, in this case, it act as an acid. In this case here, act as a base because it accepts H plus. Same thing with ammonium ion. Ammonium ion, of course, if this equation go forward, give plus H plus here. So ammonium salts are acidic. Why? It's an acid. Proton donor. Okay? Right? Now this can also go backwards here. That means this is a base. Why? Proton accepted. Now this is a famous fellow here. Remember now? From here, right? So here, it acts as an acid. Y can go forward and plus what? Plus H plus. So it came up before also. Okay? And it's 2 minus. Okay? So ammonia can act as an acid, no, under conditions of it's a no water one. Okay? Right? Okay? So some examples. Okay? Now, 2 ways to consider strength of acid. Alpha, it means how much it dissociates. Right? If alpha is 1, that means it's 100% dissociated. Okay, so alpha, normally now we don't use alpha anymore, no, in exam, in CIE, right? So if alpha is 1, that means 100%. Okay, like I said, dilution, when you dilute from 1 molar, you go to more dilute, it will dissociate much more. Because why? HNO3 plus equals U, H plus, and O3 minus 1 equals here and equals here. So increases one here, increase water, you shift more, so more will dissociate. Okay, similar here. So half H2O4 because 1 mole give you 2 moles of H plus. So comparatively, we need to have only 1 mole H plus. That's why I put half here. Okay, see the eternal acid is very low, right? Because it's a weak acid, right? It will only dissociate partially. Okay, now the other one, of course, is more important is the dissociation constant, okay, the Ka. Right? Now, the bigger the Ka, the more acidic. Why? Because Ka is a measurement, let's say, for example, here, okay, this one I've used this one, this is common acid, okay, CH3, COOH, plus equals must have water, no water cannot, use CH3, COO minus plus your H plus. Okay, so your Ka, no Kc anymore, it's equals to, of course, the CH3, COO minus, and your H plus here over your concentration of CH3, COOH. Okay, now this, right, undissociated is not acidic, it must dissociate. So remember Ka, if this H plus here increases, right, that means it's a strong acid. Right now, so a big Ka means a big Ka means stronger acid. Small Ka, weaker acid. I comparatively compare here. Okay. We did this before in your organic chemistry. Okay. Okay. So K, now this one, right? This one is bigger, isn't it? This is the strongest acid of all. Oh, this is the strongest acid of all. Why? Because Cl will what? Cl here will withdraw electrons, and of course will weaken the bond here, the OH one here. So come out easier. So all done before already, I'm just revising with you, okay? But today you must know that a big Ka, a large Ka, strong acid. But then your log, I told you, your pKa, it's opposite, right? pKa, right, large, weak acid. Small, strong. Okay, you will ask you one. Okay, so now this one here, binary system, you can look at yourself, okay? Because why? Now, here, okay, I develop this for you because it's very simple. Okay, binary means I got A and B, only 2 substances, and not 3 substances. Okay, 1 more here, give you one more, right? The H plus is known as H plus. Whatever here, don't care, right? So at time equal to 0 is 1 mole, 0, 0 moles here. Time equilibrium alpha, alpha is a degree of dissociation. So alpha, alpha, okay, so one mole dissociated, get 1 mole out here, okay? So alpha dissociated, alpha, okay? So normally C is very small because it's a weak acid, okay? Alpha is very small, very small. Why? Weak acids. Like here, you see, right? Weak acid, see, very small. Very small. This is alpha. Okay. So here we go. So if you law of mass action, K, remember your equilibrium constant, Ka or Kc. I put Ka because it's acid, isn't it? So it's equals to, of course, your here your Kc or Ka is equals to concentration of H plus. And what? Here will be your A minus. Better use because now they all use this in exams. So let's say it's HA here. Okay, so it's AH plus and your A minus here. Okay, over this is asked, I just show you afterwards, over your HA. Okay, so if you substitute the values here, okay, these two is same, C alpha, okay, so over this one here, C minus 1 alpha. So on the C can cancel. So C alpha squared over 1 alpha here. So for weak electrolyte, alpha is very small. So you can see Ka equals to C alpha squared. Of course, then bring up here, right? It's here. Okay. Or you can say concentration of H plus here. Now this is used last time, but they no longer use it. Okay. So but this is more often used. So H plus is equal to C alpha, right? Alpha is equal to this, so substitute inside here, you get C root of Ka over C. You bring C inside here, is C squared, so cancel C here. So H plus is equal to, this is the famous one. This is number 1, okay? So concentration of H plus is equal to root Ka times concentration of whatever acid you got. Okay, now this is the key to all your answers, all your questions. You can see afterwards, it's the main equation. Now, the other derivative equation, which is also good to remember, is this one here. Okay, now remember this is the one here. I can square both sides, square here, and square here. So, right, then this is the root has gone, right? So I get H plus squared equals to K, A, and C. So I log both sides, I also minus log both sides, of course, you get, okay, those who are not good at maths, I'm not very good too either, no? I put 2 log H plus equals to log 10 Ka plus log base 10. See there, I change all the signs, minus, y. I want to change to pKa. So this equals to 2 pH equals to my pKa. This is very useful, minus log C. This is very useful. So this equation and H plus is equals to root Ka times C. These are the 2 equations which you need to remember. Okay, and one more equation. Okay, now same thing here for base, right? You can use this one here for base. I don't know why this thing is playing up. Never mind. Okay, so same. But this is seldom used anyway. We use this one here to find the pH of a base. Remember, pH is always equals to minus log base 10 H plus. H plus is also present in alkaline solutions because of this thing of water. Now, as I told you, water is reversible, this one here. So this is your Kc, by the way. It's not, So you bring this one up here. They ask you, of course, the H2O here times your Kc is equals to H plus times OH minus, okay? And it's equals to 10 at this one here. It's equal to this value here. I'm going to show you a question. It's quite a ridiculous one. They actually ask you on this, okay? Okay, page 13, page 13 of this first 13. So say I prepare a lot. No, I'll tell you, take a few hours to prepare. Okay, here we are. See now, water ion is more extent. See now, they give you the equation here. Okay, let me put this value, this in here. Okay, right? They give you the equation ionize is small extent, and the plus is endothermic. Okay, so write expression for Kc. Remember it's Kc, yeah? Right, so here. So you can see our water is in. Now the answer is here. See? All done already now. See? With the water down here. Okay, this is Kc. Now they ask you a Kw. Kw. Okay, they ask you a Kw. Okay, write down the expression for Kw for this is called the ionic product of water. Why ionic product? This times okay, ions and product multiply, isn't it? And explain how can derive from your Kc. So you derive from here and you just ship out here. Okay. So now see how the answer here. Okay, see now. Right, it's good. This one here, rearranging of the equation, that's all. Okay, just put down rearrangement of the equation. One gives you this value here, and that's why is Kw equals to okay, that's all. Okay, or this is contained in Kw. Okay, this quite simple explanation. Some think it's like rocket science. It's not. Okay, simple things. Can? All right. So here, of course, they ask you, still explain how the Kw for hot water will differ from cold water. Well, the Kw will be bigger. Okay, why? Because it's endothermic. It's not. Okay, because endothermic. Right, see here, Kw is bigger because endothermic. Right, Kw is higher or bigger in hot water because its action is endothermic. Okay, so now let's go back to here and go to here. Okay, so all this is calculations. Now let's go back to theory again. Okay, now we won't do all this we won't do. Okay, now let me just pause for a while. I want to change that one. Okay, pause. Okay, now very simple. Now just show you an example here. Simple one, okay. These two examples is repeated umpteen times throughout the whole partial question syllabus. So, famous question: what's the pH of 0.001 molar HCl? When they say HCl, it means that they assume it's completely dissociated. They don't have to tell you. Okay, that means you assume it's 100%. Which means if HCl is like this here, HCl here equals to one direction plus Cl minus. Okay, 1 mole give you 1 mole. 1 mole is enough. So if it's 0.001 mole, it give you here with how much? 0.001 mole. Which means the concentration of H plus is equals to how much? 0.001 mole. Okay, so what's the pH? pH is equals to minus log base 10 H plus. Okay, very simple. Minus log base 10 0.001. Okay, you want to put it nicely, it is minus log 10 to the power minus 3. So actually it's equals to 3, minus 3 equals to 3. Okay, simple as it, right? But this one, if it's alpha, now I said no more is already, okay? We're going to work on Ka, right? Alpha, they don't ask anymore. Well, the thing is too difficult for people like you and me. So never mind. Okay, here. I calculate the pH of 0.01 mole of ethanol acid if the Ka is going to be very simple. Now there are two ways to go about it. All right, two ways to go about it. Here, let me do it here first, okay? Remember, you can use K here. Let's say you put HA, okay? Is equals to H plus and, sorry, reversible. Yeah, what am I doing? Okay, never mind, we use straight away I don't want to go through everything, okay? I just go straight away. Okay, remember, concentration of H plus is equal to what? Root, this way remember, Ka times what? C. Equals to what? Root 1.8 times 10 to the power minus 5 times what? 0.01. Okay, now. Okay, so to make it easier. I don't know how you do it, but my maths teach me like that, like to make it 6. Okay, it's 1, 2, 1, 2. I think okay, it is 0.01. 8 times 10 to the power. If I shift here, shift 1, goes 1 here. Okay. Okay, 1 here. So sorry, 0.0. See, my mass is going up. Okay, 0.0. Okay. 0. I want to make it easier so that I can don't do too much. 0. Okay, times 10 to the power of minus 6. Okay, so root of that 1.8. Calculate here. Root of 0.18 equals to, okay, 4. Where is the cursor? 0.424 times 10 to the power of here is 6 minus 3. Okay, so you go down here. So pH is equals to minus log base 10. This number here is 0.424 10 to the power of minus 3. So for this equals to 3 minus, what is this? Log 0.424 equals to minus 0.373. So it's equals to 3.373. Okay, okay, so it's a pH. Okay, all right. Okay, now I will go now straight to calculation already. All these things, okay, right? I will leave all this number. This all this here. Now let's go to here now. The real stuff, okay? All right, now here, starting here, expression for Kw quite simple, right? If you can write it from memory, or you can do the whole thing out like water, reversible give you H plus OH minus, right now. Right now, so the Kc is equals to blah blah blah, and OH minus over the water. But remember, Kw don't have water, isn't it? So what? You put Kw, you bring up here, and it becomes Kw. It's called the ionic product of water. Okay, so Kw, they only ask for Kw equals to H plus. What am I doing? Okay, and product. Okay, right? As you can see, this is the answer here. Okay, see now. Okay, right? You can put this on, but this is better, easier. Don't forget the H3O. Okay, here. Expression will help you to calculate your pH of this one here. Now here you must use an ionic product of water. Remember, this you consider as a very strong base. It means I'm going to remember this is the complete dissociated. So one more, give me one more here. Okay. So 0.2 moles gives 0.2 moles. That means OH minus here. So remember in the solution of any OH, right? Even though it's alkali, right? It contains H plus because of water. Okay. So the two must give you, the two concentration must give you the ionic product. This way the ionic product of water is very important. So I know this is 0. I'm going to put blue color so for us to see the difference. Okay. So this is your 0.2. So what's H plus here? So you bring up here, blah, 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 do here. Now this is the value. Okay. Right? This is H plus, no, inside the H plus of constant H plus inside your alkali. So pH goes to minus. Now pH is for H plus and not for OH minus. OH minus is POH, but that's not important to us. We don't care. Okay, so you get here, you can use, make sure you know how to use your calculator. It's 13.3 here. Okay, in fact, the answer is 13.3 and they give you until there. Okay, it's 13.3. Okay, which is true one. It's not, okay, cannot. Okay, of course, this one here we did before that. Okay, but the same molarity 0.2 of anyways is less than this one. It's less alkaline, lower pH. Why? Because it's a weaker base. It means ionized partially. Okay, so it's ionized partially, weaker base, right? Weaker base or incomplete ionization. Remember, ionized partially, easier word. Okay, ionized completely, partially. That's what I call strong base, ionized completely. Use the word ionized, don't care. Okay, right? The answer all here. Okay, the second one, expression for K, easy, is it? So remember, you always, Ka, you can put the whole thing. Sometimes the acid is very big. You can put Ha, I told you already. Ha, the general form, you always can use H plus H and A minus. So Ka, no more Kc, yeah? H plus and your A minus over what? Ha, okay? Okay? Or you want to see the answer. They put like this one. They put like, never mind. But normally put like, okay, put like can, no worries. Okay? Let's do it up here. Okay, we got space. So remember your H, methanol acid, reversible is a small, that's why they say put the whole thing, COO minus CO, yeah, right? H here, sorry. So Ka is equals to constant H plus and your HCOO minus over the acid. Okay, right? This expression and calculate the concentration H plus here for this is the concentration, okay, in the solution methanol acid. So again, see, this equation, famous equation, root KAC, right? Put the K inside here, the C inside here, and voila, you solve it. Okay, so now this is the amount of H plus that came from this original. It means only very little amount of it has dissociated. Count the percentage of molecules ionized. So the amount of ionized here is H plus over the original is 5.94. 5.94. Okay. Right? Okay. So pH, of course, calculate the pH of the solution, easy. Right? Equation, just put inside here, put your constant H plus inside here. Yeah, put inside here and you solve. 2.53. You better know your maths. 2.5. Okay, 2.3. Okay, up to you. Right? Okay, part B. Okay, I don't have part B. Never mind. Okay, now here. Another one here. Okay, now this is, we'll do this a little, okay, this diagram here, don't care about this. You can see here, this is actual titration. See, when 25 cm cube of dilute H2SO4 was saturated against the guanidine. Okay, so for that means here is guanidine, is a base. Before titration here, now this is the pH of the H2SO4, pH of the H2SO4. Okay, so you can see around there. Okay, strong or weak base, you can see here 14, is it? Right, so it's a strong base. The pH of the start, they say is, because can't see very clearly, so they say it's 0.7. Okay, cover the H plus concentration and hence concentration of sulfuric acid start. Okay, so the pH is equal to this one here, right? And you anti-lock it, you get this one here. That means for H plus. Okay, H plus only no. So you go back to the original, right now, to H name. So you want to find the H2SO4. So this is 0.2. So original is 0.1. See now, let's come from 2 mostly 1 more. So the answer is there. See, this is H plus. This is H2SO4. Okay, so all maths. Okay, here now this is ibu, some people's mother, ibuprofen. I think it's used in headache and things like that, used as a painkiller. Okay, blah blah blah. Remember that this is a benzene ring. You can do A2. This is your carboxyl acid here. Okay, got all groups here. Draw a circle on the chiral center. So simple here, of course. Okay, formula, molecular formula, and so forth. Calculate MR with that. We're going to do this. Okay, MR is goes here. So vigorous oxidation of different content dibasic acid there already. So containing some. You can calculate out. Actually, you get all this will be oxidized now. Remember now, this is your A2. Or give it. Actually, you can find it. This is one here. From the AR, you can see this is the one here. Okay, so the K for ibuprofen is this one here. Now this is where the calculation comes in. Right, expression for K. See, it's a big thing here. Of course, you write your HA lah. No, right? So you can see here. See now, see? I know. This is a very acceptable one. Okay, H plus and A minus. Okay, it's 1 mark. 1 mark. Okay, it's 1 mark. Okay. Use a K in the value to calculate pH, calculate the pH of Simple, isn't it? Of course, find the H plus first. We again root KAC. Simple. You put in your Ka values, which is this one here. Masuk sini. Okay, and then your times your concentration result is this one here. Okay, find here and log 3.01. Okay, see 3.01. 3.1. Okay, 3.1. Wait, 3.1, 3.01. No, here. 3.01 here. Okay, right? Easy, isn't it? So it's the same thing. Let me just, okay, now here. Use the general formula of carboxylic acid, R, blah, 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 right? Equation for, okay, of course, if you want to write this one, then you better write the whole thing. Okay, so RCO2H reversible RCO2 minus plus H plus. Okay, so your Ka equals to this whole thing now, RCO2 minus, actually you put the HA, they should not be wrong now. Over this one here, RCO2H, okay, right? P is minus equals to log base 10, important, your Ka, okay? So this is here. Let's see the marking scheme. Okay, so the one explain, okay? See, log, see, okay? Not long, okay, so be careful. All right, now so pKa, remember, the smaller is it, the more acidic, right? This is the most acidic. Why? Because the Cl, remember not, first of all, Cl electron withdrawing and got 2, isn't it? This has got 1 only, right? This has got none. So of course, the acid will increase. And so this is why they ask for trend 1, 2, 3. This one here, why is this one here, right? This one here and this one here. Why this is more acidic than this one? Because the distance, okay? This all I explained already in your A2. I'm not going to do again. Okay. Now here I said this you can see how the actual formula comes in very handy. Calculate the pH, right? Remember you give me a pKa, isn't it? Huh? pKa. So you can use it a bit. pKa is you can use, okay? Then calculate the pH of this concentration. So I'm going to use this formula now. Remember, there are two formulas. Use this one, this formula, and of course the other formula, which is what? Which is your concentration H plus equals to root KAC, right now. Okay. So, and then this is one formula, and of course the other formula is your pKa equals to minus log base 10 K. To solve this one, you can use these two formulas or just one formula now. I prefer this one here. Now, now, see how I use this formula, okay? 2 pH equals to pKa. I got my pKa is 4.9. Simple as that, 4.9, okay? Log concentrations on here, okay? Give here and answer straight away. But of course, I see I put down here, now you give 2 ways, 2 ways here, see now, here. Of course, you put half here, I don't know how to put 2 in front here. See? Right. Okay. Now, or you can use this one here. This is pKa, remember? pKa equals to minus log base 10 K. You just reverse it, you substitute that, do all again. Either way, correct. Which one you prefer? Up to you. Okay, next one. Again, I told you already, bronze and base, simple here. Proton acceptor, acid is a proton donor, base is a proton acceptor. Strength of acid, again, we're not going to talk about this. Okay, now here, come to the pH, pH of this one here. Simple, isn't it? Okay, same thing. H plus equals to root KAC, you substitute inside here. Ka is given here for this acid here. K is given. Okay, substitute inside here and then find the pH. Easy peasy. Okay, next one. Okay, now here we done already, all right? Okay, right, now here, Kw can be used to calculate pH of strong and weak bases, okay? Use the value in Kw in the data to calculate pH of, now remember, this is NaOH, so I expect you to know this is a strong base. That means it will give you the same, for NaOH, this will be the same as your OH minus. Okay, so same here. So use your Kw to find the H plus here. I told you before. put it here and get H plus and substitute inside here, you get your pH. Okay, so this for a strong base. Now weak base, ammonia, it's a bit different, so they help you a lot. Okay, remember it ionizes partially, plus water give you ammonium ion and OH minus, right? It is a proton acceptor, it takes the proton here, H plus, okay, to become some here, right? So full expression, you can bring blah, blah, blah out here, you can write it down actually, okay? Right, this is actually, you look, it's Kc is equals to NH4 plus and your OH minus over your ammonia, if you want to put and H2O, okay? You bring your H2 up here, all right? Get this one here, okay? And this one here. This is go to this, okay? Which means you're going to use this one. Remember this, if this X is also X here, this is important. Same ratio here, right? So this and this are equal. X moles per dm cube. This is the important part here. So calculate OH minus in a 0.5. This is the concentration of ammonia now. 0.5 C. You may assume the only a small fraction of NH3 ionized. That means this one here is the same. Remember I told you here, NH4 plus and OH minus is the same, isn't it? Why? Because one more here, one more here, gives you one more and one more. So this and this are the same. That's why you can calculate. Otherwise, very difficult, man. Okay, same here. So remember this whole thing, right? X squared over, you see, use from here. Why not? From here. So is X squared over ammonia is 0.05 is equals to 1.8 times the power of equals to 1.8 times the power minus 5. That's what I put here. Okay? Right now. So for X, OH minus, right, this is the value here. And use a KW in double to find H plus. Again, use your ionic product of water here. Okay? H plus, you know, from the OH minus here, you put inside here. H plus, log base 10, solve for your pH. Easy then. Very simple. Okay. They're doing fine. Okay, you can see here. Right? We go faster. Expression for KW, again, very simple. Expression uses for KW to calculate pH of this one here. That means, again, for NaOH, you assume it's completely ionized. Therefore, this equals to your OH minus ion. Again, use the ionic product of water, KW here, and find H plus, and again, solve for your pH. Very simple. So I want to explain it. It's, okay, see here, 13.18, 10.2. Okay, I did all coverage by myself, no? Now here, this is a bit tricky one. Using the symbol HZ represent acid. Why? Because there's a H here to be donated, means can give you H plus Z negative. Right equation for the showing the following substance acting as a Lorentz balanced bases. Okay, a base, that means it must be what? Accepting a proton, the HZ. That means NH 4 positive plus your Z minus. This is an acid, this is a base. This is a proton acceptor. Again, now HZ. Okay, now, right? Which showing acting as a base now. See here. Okay, this is tricky, isn't it? Because remember in your lower 6, CH3 OH2 is positive here. Why? Because got lone pair, lone pair, yeah. Okay, plus of course your Z minus. Okay, see now, 1 mark each. Using the B minus as a base, write the equations which the following substance. Okay, SS. Okay, I think as acid means B minus here. Okay, see now, come out. See, it's down here. That means this must be a proton donor. So get NH2 negative plus your HB. Okay. Again, this is your base here. Get your methanoic ion CH3. See, this kind of funny thing to ask you. Plus H. Yeah. See? 1 mark each. Okay, so this is how the syllabus comes out. Propanoic acid, weak acid, Ka, again, pH of concentration, this is your C, this is your C. Again, see now this equation, fantastic, isn't it? Substitute inside, any fool can do it lah. Okay, right, here another one. Okay, the Ka is given, ayo, okay, why, explain why this K is larger than this. Okay, now you have to know, right, compare these two. Why? Because the C11O here is an electron withdrawing group, isn't it? No, this have been done before, okay? Electron withdrawing group weakens OH minus, therefore stronger acid. Or stabilizes the anion, we done before. Y is smaller than this one here, right? Small, that means this smaller than this means it's more acidic because the Cl minus electron withdrawing and will weaken OH1, okay? Oh, always the famous, okay? So, carrier pH again, this is the concentration. Right, your K is given in front here. All right, so just substitute inside here. Okay, right. Remember, this equation is very important. No more the alpha, only the Ka. Okay, you can see the answer here, 288. Now here, a different way of asking. Tartaric acid is represented in many plants. Okay, tartaric acid is, I think, is present in apples. I think. Tartaric acid has two dissociation constants, K1 and K2, which is 2.99 and 4.40. Suggest equations of foreign dissociation constant appear. Now, suggest the equation. Okay, now remember this one here, there are two carboxy acids here. Remember, this is not an acid, okay, this is alcohol. So these are the main dissociation. It means they can one by one, okay? The first one to go is stronger, okay, like H2SO4, right? Okay, the first one, H+. This is a stronger acid, you can see afterwards, okay? This is a stronger, the K of it is bigger, K1, than your K2. It's harder to remove the H+ from negative ions because it will attract back. Obviously, electrostatically, it's hard to lose the others. Like say, this mother lost the first son. The mother lost first son, want to give the second son also, but it has to in this case it's harder to go for this one here. Okay, so this is for the first one. Second one, I'll give you an answer here. See, either this or this. Okay, the first one here. Second one here is the second dissociation. Of course, this fella have to go. Okay, to get a 2 negative sign here. Okay, right. I will teach you this one later on this stereoisomers. Okay, this is I think I taught you before. I don't know, but that doesn't matter. Okay, now this one propanoic acid, weak acid. Again, Ka is given. All right. Okay, find the pH of solution. Again, same. Okay, you can go through here yourself. Right, and here. Again, this one here, Ka is given. Right, find the pH. Concentration is given. Again, this one here. I've done through all these things. You can go back and look at it. I want to finish off in 10 minutes time. Okay, same thing here. All right, find the pH. Concentration is given here. Ka is given here for amino acids. Okay, which is here. 9 point. Your pKa. Fantastic. Okay. As I said, I like to use equations. This one here. Fantastic. Just substitute inside here. Or use the law method lah. Use a Ka. You want to be stubborn? No. Ka. pKa is equals to minus log base 10 Ka, and then you're gonna find your your H plus is equals to root Ka C, okay, and the whole rest my test. Okay, you see here, this is what they did lah. Stupid buggers. Okay, right. Okay. Now here again, see 2 stage. It's quite a common thing to give a dicarboxylic acid. Okay, 2 Kas, K1, Ka1, Ka2. Okay. Now here, not only that, they say as n increases, that means further distance are separated. That means the effect of this one on this one here becomes less and less now. That's why as you go down here, right, the acid becomes weaker because the OH here cannot pull with electrons from the OH minus. Okay. For this one, the first one here got 2 COO, got 2 this one here. The second one only got one. Okay, you can see it from above. Okay, smaller and so forth. All right. Here, same thing. Hydrogen cyanide weak acid equals solution here. Ka is given, constant given. Again, use this formula. Right? Okay, easy busy. Okay. I got all the answers here. I'll post it in the net for you. Okay, now this one here, pH. A bit different here. pH of a solution obtained by sodium oxide added to this one here, water. Remember, you must know the equation. Okay, they ask you here. Sodium oxide reacts with water, give alkaline solution. Explain why the solution is alkaline. Use Lloyd-Bouncer theory. 2 marks. The first mark, of course, is given for sodium oxide reacts with water to form what? To form your sodium hydroxide. Because sodium oxide is not a base, because it does not accept a H plus like that, you have to from here H2O. Okay, 2. Okay, now sorry, what am I doing? Top rubbish. OH minus. Okay, no need. Okay, 2. That's not. All right. Okay, so here. Then the second one, of course, is NaOH gives you Na plus. And don't put 2. Okay, so 2 of them, see the marking same. The reaction produces sodium hydroxide. Okay, and sodium hydroxide gives you OH minus. So an OH minus is a proton acceptor. Okay, for 2 marks like that. Okay, so here comes the pH solution. So give you sodium oxide here. Right, remember 1 mole give you 2 moles. The equation very important. Okay, so find the number of moles of NaOH is 0.05. So number of moles of NaOH, Na2OH, Na2O. Sorry, I'm trying to hurry. So this is 0.1. Okay, because why? 1 is to 2, isn't it? So 1 year, 2 year, 1 year, 2 year times 2 lah. Okay, so number of moles of NaOH is this one here. So use your onion product water, right, to find the H plus, and then use your pH. Okay, 13.4. See, correct. Make sure you know how to use anti-log, all these things with your calculator. Okay, next one here. Okay. Now, nitrous acid, so far difference from acid, because easy, isn't it? Right? On ionized, you can see here, ionized partially, ionized completely. Okay, must put 2. All right. Expression for Ka. You see, I put the equation here. If there's small values here, then you can put the whole thing. If there's big, giant formula here, then put Ha. Okay, easiest to do. Calculate the pH of this one here. This concentration. Again, use a Kc or Ka given here. Right? So, see how important the question is. Percentage, of course, will be the amount here, not the pH. This amount here, which is K plus over the original concentration, 6.8. Okay, 6.8. See, all right. Okay, next one here. Now, this is interesting. This one you learn in your AS. Silicon chloride, tetrachloride is a very is an acidic chloride plus water. The equation is very important. So 1 mole will give you 4 moles of HCl. Remember? Okay, right. So 2 visual, of course, is solid. And this is what? This fumes, white fumes of HCl. This solid, this sand. Okay, so visual is 2 visual things here. 2 visual things, okay? Right, it's solid, and steamy fumes and misty fumes. Okay, right. So now here they ask you, well, a sample of so many grams of silicon tetrachloride was added to water. Okay, so my water is blah, 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 blah. Of course, find the number of moles of silicon tetrachloride is here. So 1 mole give you 4 moles, times 4. So number of moles over the volume here, this is the molarity of HCl, complete dissociation. It means same here for H plus, and you find your pH. Easy, isn't it? Right? You go backwards, it's all like going backwards to find the answer, which is how much here? 1.6, 1.6. Okay. Okay, here, see, under product, so it's simple. Now, this one they test you on understanding. the numerical value of Kw will increase. Of course, why? Because endothermic is for hot. Okay, take appropriate one to show the effect of increasing temperature, right? On pH and ratio. pH, of course, the pH will decrease because the concentration of H plus will increase. So will increase. But the ratio means the same. Okay, right now, because here the same H2O give you 1 mole and 1 mole, same. More dissociate, more here is the same. Okay, now the answer is the same. Okay, still the same, right? Okay, so this is how they trick you lah. Of course, then they ask you, crystal of sodium hydroxide is pH is one here. Okay, how the concept of here is one? It's very simple. You just go backwards. Okay, pH is equals to, remember this is NOH, no. So remember this H plus, go backwards, right? You anti-lock it, then you go use a KW, okay, and find the OH minus here, right? Because this one is the pH is of your H plus, okay. So the other part of your OH minus from your KW, so this is the answer, okay. All right. Okay. Next one here. All right. Now this one here, sulfuric acid. Constant sulfuric acid water, there's only two stages on that. The first one here, remember, is a K1, Ka1, so Ka2. Okay, right? Strong acid, okay, it's a strong dissociate constant. K2 is a constant for stage 2, right? Expression for K2. Okay, okay, right? Easy is it? Okay, H2SO4 is constant strong acid, whereas HSO4 minus is weak acid. Imagine magnitude of, okay, suggest how the magnitude of the stage 1, okay, larger. There's only one, larger. See, larger. Where is it? Larger. Ka1 is larger than K2. That's all they want. Okay? Larger. Okay? Now, benzoic acid is a weak acid, and this is the concentration again. I don't know why this thing is not. Okay, put it here. Okay, benzoic acid is the concentration, right? This is a pH. See? Right? So find the Ka. Two ways, this equation way or this way, up to you. I show you two ways, okay? So 2P H equals to pKa minus log acid, okay? This is your pH here. Okay? The pKa, right? You don't know, log, this is a concentration here. Put over and so forth here. And of course, you anti-log here, this answer. Or you can find from pH, right? You get your H plus, right? H plus, then you put the H plus inside here, okay? And then you can use this equation here and you square it and get your K. Either way you can do, okay? Like you can see here, either way, right? 6.3 to the power of minus 5, okay, no, same way. Okay, we're going to near the end of this. So simple, isn't it? Right? Remember, this is a Ka, this is a concentration again. Let me explain. Okay. All right. Last one. Okay, ammonium chloride dissolves in water, get acid because NH4 plus is acidic. You can see here, it's a proton donor. Ammonium ion is weak acid, the pH of 0.3. Again, is a concentration, remember? Right, solution of this is your pH. Okay, so as I said, you can use either the old-fashioned way or whatever, and of course this method here. Okay, so I would like to use this method 2 pH. Okay, right. So pH is given. pH is given here. Yeah. Okay. pKa. I want to find concentration. Sorry, here, what am I doing? Okay, here first. Jumping the gun. Look at the time already. H plus, okay. pH, this is a pH one. Okay, you put this one here. Okay, anti-lock it, it's the answer. Okay, pKa. Okay, that's two ways now. You know your pH already, right? Yeah. You know your pH here already. Okay, right here. And P, you don't need some here, concentration is some here, you put inside here, substitute get your some here. Why not? Okay. Or you can do it the other way around. Okay, concentrate H plus here, substitute inside here, this into here. Okay, concentration is here. Find Ka, right? And then log it, you get your pKa. Okay. Last one here, I think. Okay, use a Kw to calculate pure water. Easy, isn't it? Why not? Remember, H2O2, this is the equation. This 1 mole is to 1 mole. Okay, doesn't, you need a small amount only. So it's these two, remember these two are the same. They always equal one. So it's if X moles here, X moles here. Okay, this of course X squared goes to, the side pH is 7 for pure water now. pH is 7 for pure water minus log base 10. I told you already. 10 minus 7. So bring out here is equal to 7. Pure water, pH 7 is neutral. Okay. So for 50 is increased now. Okay. Remember, it's endothermic. I mean the concentration of H plus increases, the pH will decrease. So find numerical value for Kw. So here you use this to go backwards. pH is equal to this one here, right? So you log it, and this is instead of 1 here times the power of minus 7, you get 2.3. Okay, so remember this is all now. Of course, the OH minus is the same, also same as this. Okay, so if this time is out, this will be the answer for Kw. All right, see answer Kw. Okay, okay, I have finished. All right, so I would continue with the next one here with the graphs. You look at it carefully here. I just want to show you where we are up to here. So we good on good time. Today I did 2 videos now, I tell you. So we will talk about the titration curves. Okay, so about acid base. I think these two are put together. Okay, buffer will come later. We will finish this by 2 more weeks, I think. Okay, let me just stop first. Okay, goodbye, and remember, plan your work your plan. Okay, don't have holidays, just go and relax and don't do anything.